cover section 5.2, which is the approximating areas under curves. This is the second part of the video. And the last thing we did on Monday was we kind of finished example 2, but we left a few things unanswered. But just to do a quick recap, I believe the area for the left Riemann sum, was that going to be an overestimate or underestimate? Instead of under. Under. What was the area for that? Approximately? Point under? Oh, we didn't find it?
0.86.
0.86, okay. And then here for the right Riemann sum, that was the overestimate, right? And so if let's think a little bit about this, because this is going to come back to us. So we know that right here, we're talking about this little segment, right? And would you say that that is concave up or down? Concave down. No. Yeah, down. Will the water go down? Or will it stay in? Down. It will go down, right? Because that was too pour water right here. Yeah. Okay. So, and it up is like a cup, so it's definitely not a cup, right? So, what was this one? It was 1.12-ish. All right, let's say 0.2, something like that. It was not too far from what I remember. And so, the actual area, and I know we did it. Do you guys remember what it was? It was 1, right? So you have that when you have a function that it is concave down, the right Riemann sum will be an overestimate. In the left, an underestimate of the actual area. Do you guys think that would change? That would change the concavity? Yeah. I think so, yes. Because then your left point rectangles will be either not sticking out or sticking out or something. So you will have the over or under. And then we ended with the midpoint, right? And for the midpoint, well, it says here like approximate the one for the actual area. And we found it, so we knew it was 1. And we had like A is an underestimate, and B is an over. From the actual area. And then I asked you something to think about how we were going to divide it if we did midpoint, right? So that's actually what problem 3 is about. It is the same function. So then you will see, I'm going to look at the book to get this number, but you will see how the midpoint, do you guys have any guess for midpoint? Would it be over, under? Oh, that could happen. Maybe some will go over, some will be under. So then it will compensate. Yes, that will definitely happen. And it's actually going to be closer to the real answer when we do the loop. Okay? So, and then I will show you how to enter them on the calculator. So let's do this problem number 3. And so, same function, and it's nice because we actually have the graph here. So I don't have to draw it for you, it's there already. And we're talking about same function, sine x. And then we're going from 0 to pi over 2. Okay? We're also going to make 6 intervals. So n equals 6. So you can see we're going to have 1, 2, 3, 4, 5, 6 rectangles. Right? Now, the midpoint of each rectangle, of the base of each rectangle, is the one that is going to touch the actual function. Yeah, can you see that? have a midpoint is the one, the height, you trace the height, and that will be the function value of each rectangle. The function value at that particular x value. So now to tell the difference between like what are your x values, your starting and your ending, instead of calling it like x sub 1 is 0, we're going to call them the first midpoint, and you guys see the star, like those tiny on your copy. But that just tells us that we're talking about a Riemann sum, and that either we're taking the right, the left, or the midpoint, all right? And so later on, just so you know, after we get through this one, we're going to go over like quick ways to find those points, all right? Don't get too stressed about it. There's an easier way. I'm just going to show you the hard way. Okay, and then, so please don't get overwhelmed by where you're about to see. Okay, so what we're going to do first to find delta x, the width of each rectangle, we're going to take the last value, the ending point, and the minus the first point, and then divide it by n. So in our case, we're going to consider A is going to be 0, and then B is going to be pi over 2. Okay? So I'm going to go here, and I'm going to say pi over 2 minus 0, and then divided by 6. So here we have pi over 2 over 6, so it's going to give me pi over 12. Yeah, are we okay with that? That's what I should have done last time, but I didn't do the 12. So then, from here, we're going to know that, going back to the drawing, that is just the width of each, it will be actually the base of every single rectangle. Okay, all of them. Because all of our rectangles are supposed to be of the same length. So here's delta x, delta x, delta x, and so on. Okay? So now we have the base, or the width, of each rectangle. So now to find the height, we're going to be using the formula. And so that formula, well, first of all, we're going to find our first midpoint. So think about, you're going from 0, this is at the base of our first rectangle, to pi over 12. Right? So the midpoint is going to be pi over 24. So how do we calculate midpoints or average them? Two things. You add them, and then what do you do? Basic. So pi over 12 divided by 2, so pi over 24. Okay, so that will be our first midpoint. And I know you can see it on the drawing. So that's pi over 24. Now our next midpoint is going to be pi over 8. Now how do we get pi over 8? Well, this is 1 pi over 24, and then this point here will be 2 pi over 24, and then this one here will be 3 pi over 24, and then not equal, 4 pi over 24. Are we there yet? Not yet. Yeah. 1, 2, 3. Which one is it? Oh, here. Oh, okay. So that's the one, right? Pi over 8. Yep. So the next one, go ahead and write your the numbers again. So 5 pi over 4, 6 pi over 4, and then we can see this will be a midpoint, that will be a midpoint, the other midpoint will be this one. You guys start to notice something with the numerators, and it's divided over 24, so they're odd. either us. Yes. Okay, so let's continue. And how many midpoints do we need in total? Six. Six, right? So far we got 4 of them. The other ones, and I know they're not written like that, well, at least that one will get that. So then we'll have 8 pi over 24, that will not be a midpoint. But then we'll have the 9 pi over 24. And then we'll have 10 pi over 24, not a midpoint. And the last one will be 11 pi over 24. And that will be our last midpoint, guys. Our last point is pi over 2, which is equivalent to 12. Thank you. So 12 pi over 24. So you see this midpoint, the last midpoint is like 1 pi over 20. I keep saying 4, but I mean 24. It will be 1 pi over 24 before it gets to the pi over 2. Okay, that will be our last midpoint. So now the way we're going to set up this problem, we're going to say that so don't be afraid when you see those little symbols. That will just be the midpoint of the first rectangle. Okay? And so that one we already established is going to be pi over 24. And then x of 2 star will be the 3 pi over 24. The third one will be the 5 pi over 24. And then we have that 7. Nine and 11. And I know this is taking us very long, but like I told you, there's a short way, like a formula, a general way to find those points. Okay. Okay. So now the way that we will extend it, and this is the notation that you will see on this particular textbook. So it will be the f. This will be the height of each rectangle. So it will be the function value for that first midpoint. Okay? That's the height of the rectangle. And then what's the width of the rectangle? Pi over 12. So we know it's delta x, right? So I'm just going to leave it like that for now. But yes, it is pi over 24. And so we keep doing this, and don't worry, we're not going to write all of them, okay? Let's write the second one. And then the very last one, which is the midpoint for the 6th integral, rectangle. Okay, so now what is the function that we're talking about? Sine of x. So we'll put sine of that midpoint. Which we could just, at this time, let's just put the pi over 24. Sine of pi over 24 times the delta x, which is pi over 24. No, delta x is pi over 12. Right? Delta x pi over 12. Okay, and so we'll move on that way. The next one is going to be sine of the second midpoint, which it is 3 pi over 24. So that value times pi over 12. And so we do that all the way to the last one, which will be the sine of the 6th midpoint, 11 pi over 24, times pi over 12. I think you guys can totally do this homework on Friday. You might be able to. If you start today, if you at least open it, maybe you can finish on Friday. Okay. Maybe. Okay. Okay, so next thing. So now how can we maybe perhaps create a little, using the So for summation, let's see. If we start at, let's say I equals 1, right? So we're gonna try to get that number right there.
Can you start at I plus 0?
We could, yes.
Because in that case, you could say 2 times I plus 1. So like it'll be sine of 2I plus 1 over 12.
So let's see. If we take the first one, right? It will be sine of
2 times 0, which is 0, plus 1. Oh, and the pi. I forgot the pi.
So we'll just put pi here.
Yes.
And over
24.
24. So we can put the pi over 24 here. So with the first one, we'll get a 1. Let's see if it works with the second one. So we'll have sine of 2. This is like the general form A is thinking about, okay? I have another one, so I'm going to show you. So, and if you have another one, let me know. So for this one, it will be, she said start at 0. So the first term, because our index, our lower limit is 0, okay? Remember, you can make that whatever you want. So then we do that, and then this one will turn like a counter. We'll just go up by 1 integer. Yeah, computer science. And so then we add the 1, right? The A is telling us. So let's see if it works. So it will be the sine of 3 pi over 24. So it works. Very nice. If we do the next one, we will put a 2. Like if we do the third term, we'll put a 2 here, and then we will have the sine of 5, right? 4 plus 1, 5. 5 pi over 24. Okay. So now, let me show you guys mine. So that will be, let's write both. So now, should I stop at 6 since we started at 0, or should I stop at 5? So then this is going to be the sine of 2I plus 1. The other one here. We're just going to use our fraction tool, okay? And then what else? Is the function times delta x, right? Which is pi over 12. And that one is constant for all of them. Did I see? Pi over 12. There's the width of the rectangle. Like that. So that will work. Now let me just write mine. It's kind of very similar too, but I started at 1. So let's say I equals 1, and then I will go all the way to 6. And so what I did, I used I used 2I plus 1. Oh, minus 1.
Oh, okay, that makes more sense.
Minus 1 is what I put. So the very first one was for 1, when I is 1, the first term, it will be 2 times 1 is 1. No.
No, yeah, you got it right. 2 and then minus 1, you get 1.
2 minus 1, I get 1. Yes, yes, yes. And then for the second, it will be 4 minus 1, 3.
Oh.
And then for the third, it will be 2 times 3, 6. 6 minus 1, 5. Woohoo! Yeah. So, and that is the characteristic. Anytime you want to get like all even numbers, you could always use 2k or 2y. But like in theoretical math classes, we use k a lot more. And then, so this will be an even integer because you're assuming that it's always divisible by 2. And then to say odd, you know it's either 1 before or 1 after, right? So then it will be the 2k plus 1 or 2k minus 1. That's how you can say odd. Okay? All right. So let's just practice others. How we're going to put them in there. So we can just move on. Hold on. And, well, let's just write the answer. So you guys can just do that at home when you get bored, you know. Do you ever tell your mom, like, I'm bored? Because the shows make you do something? Your mom? Did you tell her that?
My mom's like usually doing something, and I'm usually doing something. So if I'm bored, I just find something to do.
Yeah, that's what I do with mine. Okay, so for that one, the answer is 1.003. And we know the exact answer was 1, right? So you see how much closer that one is? And then what Kayla was saying about the compensating, you guys see here it goes over, but then here it goes under, so kind of like counts. Here it goes over, but then this one goes under. So that's why. Yes, it's very close. So, okay, the idea with all these Riemann sums, yes, go.
For example, that one
But like that will be the area of all the rectangles that are under here.
And what?
Well, what are we talking about? This is not an applied problem.
Alright.
But on some of the homework problems that I just assigned it, some of them talk about velocity, and then when you integrate that, what do you get? Precision. So here they're calling it displacement. So, but yes. And then, what's the difference between precision and displacement? They're the same? Okay.
Yeah.
And then there's another one that talks about density and I don't know what's the other one. Yeah, I did it. This is a tiny little technicality there. Okay. I had a professor that used to use like when you walk your dog as an example because your dog kind of wanders most. So the dog's displacement will be there. Okay? The distance will be bigger. We'll have the same displacement because the distance travel. Okay. All right. So let's go to the next problem. And this one is very easy. Okay. This one is going to be quick. So let's say that you get a table and you do have a couple of those in the homework. And so what we're trying to do here is find both the left and the right Riemann sums, okay? So just in general, the for the left one, and I'm using uppercase A for area, okay? And that is going to approximate. Okay, so if we take f of 0 right here, so our interval will go from 0 to 2. So then we have that, and we also have here. So we're going to say that our starting point is 0, and our ending point is 2. And we want to have 4 intervals, which is just not so many, right? So with n equals 4, to find delta x is going to become b minus a over 2, not over 2, it's over 4, because we want 4 intervals, right? So then that would be 2 minus 0 divided by 4, half. So 2, 4, 2, half, yes. So that's going to be our delta x. And then do you guys remember from the previous problem how delta x is constant, right, for all? So if this is going to be my left point, the one at the left, the first rectangle's height, okay? And then for my second rectangle, I'm going to use this one as my left point. So then it will be, not f of 1, sorry, but it will be f of 0.5. And then we'll have delta x there. Now, it's going to go on like that until the last one, that is going to be, so this will be my first second, third, and fourth left points, all right? So then the last one will be 1.5, and then delta x. Now, if we factor delta x, you know that we're going to get, since they all have delta x, we can do this. Delta x times all of those numbers. Well, all those function values, actually. Oh, I didn't even do this. I just, well, missing one. Leave more room here. And remember, we have delta x here, right? That's why we need a double.
Is it supposed to be a 1?
Double
We
parentheses.
have 1.5. We have 0.5, 1.5.
Oh, this is supposed to be a 1. Okay, sorry. Okay, so now the area. The area is going to be approximately, now I'm going to substitute my delta x with 1/2, right? That's what we found? From here, this is delta x right here. So 1/2, and then I'm going to get all those function values from the table. So what is f of 0? 1. So we can see them from here, right? This is what we're looking for. So 1 plus, what's f of 0.5? 3. What's f of 1.0? 4. And then what is f of 1.5? Okay. So then if we add all those numbers and then we divide them by 2 or multiply by 1/2, we're going to get 7. 7.6.
Don't you get? So you get 6.5?
No.
Oh wait. I'm sorry. I forgot to add that one. My bad.
Yeah, 14. Okay, that was the left. Now let's see what's happening with the right. Would you guys say that this function is increasing or decreasing?
Increasing.
Yes, right? It's increasing. Okay. So now for the right, we're not going to use the same numbers that we have here. Okay? Now those values, and since you already understand what we're doing with the factoring the delta x, I'm just going to write it that way. So it's going to be f, not of 0, but of 0.5. That's going to be because we're doing right point Riemann sum. So we want to look at from 0 to 2. It's an HG. It looked a little.
I didn't even notice.
Like that, right? Yes.
That was great.
That's fine.
This one is in math class.
It's okay. This is not English. So 0.5 and this is 1.5, right? So since we're talking about our rectangles that are gonna touch the graph, well, you guys told me some reason, right? So I'm sure it turns like that. We want that to be the x value that we choose, okay? Because it's the right corner. Now for this one, it's gonna be 1. So that's why we start first rectangle, second, third, and fourth. All right, and that's the difference between it. So f of 0.5 plus f of 1.0 plus f of 1.5 plus f. Oh, that's it. No, I'm missing one, right? Yes, 2. Okay. Now we know already what delta x is 1/2. F of 0.5 is 3. And then f of 1 is 4.5. F of 1.5 is 5.5. And f of
18.
2 is 6. Is it 18?
Yes.
8 divided by 2 is what?
I think it's 19.
What? Yeah, it's 19.
Yeah,
Get 4
9,
plus
9,
10.
19 over 2, so that will be 9.5. So do you guys think, yes,
I was gonna ask, so if you were to get the right and the left, and you would like average them, so if we added the 2 and divide by 2, would that give us
something?
like a
Well,
ish or not really?
there's actually a mean value theorem for integrals as well.
Ooh.
Okay, so let's move on. We have one last slide, right? Yes. Oh no, we have 3 more. Okay, but they're mostly like stuff that we're gonna go over. So let's go over this one. Working with Riemann sums is cumbersome with large numbers of sub-intervals. Therefore, we pause for a moment to introduce some notation. You guys, we've been using it already, sigma. And so, of course, what's the purpose of doing all these rectangles, right? So, do you guys remember what are the main concepts of calculus? Integrals, differentials or derivatives, and what was the first thing we did? Limits. Huh? Limits. Okay, limits. So then, of course, if that's what I've been saying, I've been going over that with my pre-cal students. What is it missing for our students that are calculus? Yes. So then you keep making more and more and more and more of those rectangles. So that was what we are going to see in 5.3. We're going to teach on one. So that's the idea. We just put limit here. This and approaches. Because you keep making more and more and more. Okay? So, but let's not worry about this yet. So these are just some common formulas that will be helpful if you guys remember them. Not that you have to, but very helpful. So this is what we called the sum of all integers from 1 to n. Oh! And then this is the sum of, and you can use this for computer science. Sum of all cubes from 1 to n. And of course, this is the sum of all squares, right? And these are very quick ways to calculate sums. What else? And this is going to be the sum of what?
That number n times.
The sum of all c n times. Oh, let's say sum of all c's n times. Okay. So now let's go to the next slide. I promise you the shortcut for finding those values for like the x sub and star. It's like we're running out of variables. So whenever we want the left Riemann sum, and let's just take a moment to remember quickly what A and B are. So A and B are that would be your integral. So A and B will be like your starting and ending point. All right. So let's say that like the previous problem that we did from 0 to pi over 2, that was the interval from 0 to pi over 2. So sometimes that A value will be a 0. Most of the time maybe, but not all the time. So A could be a 1, it could be like from 1 to 10, or A could even be a negative number, because we're just talking about x value. So it's like you're just taking a little chunk of your graph and then looking at what's under it. So that's why we're using here A. And you can see that it is everywhere, whether it's left, right, or middle. right? So what we do with the left one is, first of all, we have to figure out how many intervals we're going to need, right? So then K here is representing any term, the general term, all right? So K could start at 0, or it could start at 1. Let's just say it starts at 1 to keep it like a book. And so if K is a 1, we will have, put a little start here. So it will be, I'm going to follow this, this formula to show you how they got this, right? So it will be 0, A, plus, and then from here, I'm going to use 1 minus 1, and then times delta x. So that will be A plus, what is 1 minus 1? 0. 0 delta x. And that's how they got that first one. Now, the second one, I'm only going to do the first two. So the second one, this one here, it's going to be, for the left point, it's going to be following this. It will be A plus 2 minus 1 delta x. So that will turn into A plus 2 minus 1 is 1. So 1 time delta x. And that's what we see here. Okay? Now, what does that tell you? Do you guys see like a little pattern? Maybe not yet, it's too soon. So if you're looking for the second term, how many times are we going to add that delta x? 1. We're looking for the third term, 2. We added 2. Oh. So it will be like 1 less than the index. Index is like the subscript. Okay? Right. So now for the right one, we don't have to do that 1 less thing. We just added, we don't want to start at the 0. If that was our beginning, our starting point. Let's say we want to move to 1. So then we will just do that. And that's the difference. And now for the midpoint, of course, you're going to have to consider what your starting point is. And then you will add that delta x this many times. And that would be K, like if this is a 1 for the first one. It was A plus 1 minus 1/2 delta x. So that is equal to A plus, what is 1 minus 1/2? 1/2 delta x. Okay. The next one, this one here, will be like x sub 2 star will be A plus, following this formula again, it will be 2 minus 1/2 delta x. So then this will be A plus 2 in terms of halves is 4 halves, correct? So 4 halves minus 1/2, how many halves do we get?
3 halves.
3 halves.
So it's like you go to the right and then you just take half a step back.
Yes. Okay. Now, we could have used that on that problem before, the one with the 24. So that would be like a quick way. Remember how we got those odd numbers? Like pi over 24, 3 pi over 24, 5 pi over 24, 7. Coincidence? I don't think so. Okay? All right. So, the very last one, we can finish it in 1 minute. No, maybe not. So, let's work quickly. So, we need 50 intervals, okay? So then delta x is going to be b minus a over n. So that's going to equal to the beginning. Here we have them as a and b. So it's going to be 2 minus 0 over 50. So then that will be 2 over 50 or 1 over 25. And here we're going to use decimals. I know I always tell you not to, but we're going to do it. So that's, what are we looking for? Delta x. That's what it was, all right? So if we were to divide all of this, oops, not nice. into rectangles, we will have like 50 of them, okay? 50 angles. Picture that. Okay, so then for the left Riemann sum, the way we're going to find those points is going to be with that formula, a plus k minus 1. Remember, we go 1 back, and then we multiply that times delta x. So let's figure out what we have here. So we know a. What is a? 0. It's just 0, right? And then plus. Yes. Okay, so we're going to find a simplified version. Let's distribute the delta x. So we'll have delta x k.
That is delta x.
Wait a second. Let's substitute delta x. That's what I mean. So with the 0.04. That's what I meant. So then we distribute the 0.04, so it will be 0.04k. And then 0.04 times -1, so it will be minus 0.04k. So then that one just reduced is going to be 0.04. This one doesn't have it. 0.04k minus 0.04. Okay? So then to find the Riemann sum, you will do the following with a sigma notation. We start at 1, we stop at 50, and then we're going to take that function of those are going to be our values. So it's going to be f of 0.04k minus 0.04 delta x,
Yes.
times delta x, which is 0.04 is constant, correct? So that's what you will enter on the calculator. Now, since you guys are not going to be here, I'm just going to write down what you will do for those right. That's correct. Now I'm going to be so self-conscious. So you start at 1, so just copy it so you can find it here. So it will be f of 0.04k. Remember that one we don't add or subtract. Times the delta x, which is 0.04. Like that. Okay. And that's it.